come up in. Electrolysis is a different thing. We're talking about preparation in the laboratory. We don't do electrolysis in the laboratory and biology. We're talking about simple experiment. So what do you think we will take? H2 is the first step. What else? Sulfuric acid also you can take. What else? Zinc. And zinc. Why are you taking zinc?
Among the granulated zinc because it contains impurities.
Why are you taking zinc? I can take any other metal.
Zinc has a natural what do you call that? Catalyst called copper.
Because you are reading to the textbook. No. Check that book and just pay attention to what I'm saying. Don't try to show your smartness. It doesn't work out. It doesn't work out like that.
It was in our 8th standard book.
Okay, tell me why are you using zinc?
Because it has.
No, not at all. Can you tell me any other reason why can we use any other metal besides zinc and why?
Not because of the reactivity, because the reaction.
Yes.
Like potassium and sodium.
Why?
We don't use them because they're highly explosive.
I'm asking you, can we use another metal? You're saying we can't use them. What is my question and what is your answer?
Magnesium.
Why?
Because magnesium doesn't explode on reactors.
Why? Wrong answer. Any other answer?
Can displace hydrogen.
Because?
Can displace hydrogen.
Why can it displace hydrogen?
Because high in the reactivity series.
Because it is higher in the reactivity series. Any metal above hydrogen, hydrogen is here. Any metal above hydrogen in the reactivity series can be used to displace hydrogen from the acid. Why acid? Because acid contains hydrogen and we want to take out the hydrogen from the acid. So any metal above hydrogen can be used. So we can use potassium, we can use sodium, we can use magnesium, we can use manganese, we can use zinc, we can use lead, we can use iron. But we don't use so many of the metals. For example, we don't use potassium because potassium is highly explosive. We don't use sodium because sodium is highly explosive. Calcium is expensive. Iron is expensive. Manganese, magnesium, they're all expensive. The cheapest is copper is below. Who said copper? Don't open your mouth, they'll smash you. You're talking nonsense. Copper is below hydrogen in the reactivity series. So copper will not displace hydrogen from the acid. So we can't use copper. We can't use mercury. We can't use gold, silver, platinum. We can't use these metals. So of all the metals that are above hydrogen in the reactivity series, the only metal which is very, very cheap and it is profitable is zinc. And zinc in the form of granules. Now, why are we using? Why are we using zinc granules and not zinc powder? Or why are we not using zinc metal, but we're using zinc granules? Because zinc granules has got some impurity in it, which is copper, and that copper helps to expedite it or to quicken the reaction. It helps like a catalyst. So we can get our product, that is A2, that is hydrogen, in a very quick and cheap manner. So what do we do now? We have got your round bottom flask. Sorry, we got a flask which is a flat bottom. I didn't say, I used the word round bottom. Sorry, it is a flat bottom flask. Flat bottom flask, and it is just placed on a stand. And then we've got a thistle funnel, and through this thistle funnel, we are pouring your HCl or H2SO4. We are pouring it in. Okay, this is the thistle funnel. Okay, now look at the thistle funnel, the end of the thistle funnel, and at the bottom, we've got something called zinc granules. We've got zinc granules. These are zinc granules which contain copper as impurity. That's okay. Now this is impurity when compared to granules. But for us, for our experiment, it is very, very useful. We won't consider it to be an impurity. It is to our benefit. So that's why we are using it. Now what happens is, immediately what's happening here, your hydrogen gas is being liberated, okay, and it goes through okay, it goes through through a gas jar. This gas jar is filled with water. It's filled with water. It's filled with water, and the bubbles of hydrogen are being liberated. This is hydrogen gas is being liberated. So the water will come down, and the gas is going to go up. That means, in other words, it is lighter than water. Also, it is not soluble in water. Hence, we are using it over water. Okay. Now, pay attention. So, as I said first, we are supposed to use zinc granules. Why are we using zinc granules, not zinc metal, not zinc powder? Because zinc granules have got impurities of copper, which helps in the speeding up of the liberation of the gas. Then we are using HCl or we are using H2SO4 and we are pouring it down through the thistle funnel. Then the end of the thistle funnel is below the level of the acid. Okay? Now what happens is, this is acid, this is HCl. This is HCl. HCl or H2SO4. The gas that is liberated goes through the thistle, goes to the delivery tube. This is the delivery tube and is collected in a gas jar, okay, kept upside down, filled with water by the downward displacement of water and the upward delivery of the gas. This shows that hydrogen is lighter than water and insoluble in water. Is this clear? Now pay attention here. I said we're using a flat bottom flask. Initially I said round bottom flask. Why is the difference between round? What's the peculiarity between round bottom flask and flat bottom flask?
In round bottom flask, the bottom of the flask is
round, and that is flat. That is a stupid question to answer, like the obvious. But why? Why? Because when we are using room temperature, that is not heating, there's no need to use a round bottom flask. We use a flat bottom flask because it has to remain still. Okay, round bottom flask will remain still on the table. Okay, you're not using water. I mean, you're not using fire. So it is an experiment that's conducted at room temperature. Correct? This is, what did I say just now? What did I say just now?
round bottom flask. We don't have to heat the things in the flask, we use a flat bottom flask.
I didn't say that. I didn't say that. You want to conduct your own class, you can get out. The three of you can get out of the classroom. You're free to get out. The door is wide open. Get out! Get out, Satvik! And take the exit with you and that has the exit with you also. So smart you are, if you know the matter, if you know the knowledge, why have you come here to waste your time and waste my energy? If we are using a round bottom flask we are using, when we heat, what's so special about that? The flame will go round the bottom of the flask and evenly heat the contents of the flask. Usually the contents of the flask are very poor conductors of heat. So therefore you need a round bottom flask. Otherwise if you put a flat bottom flask, the heat is only on the bottom part of it. But if you use a round bottom flask when you're heating, the flames cover up the entire body of the flask and the entire contents of the flask are heated. But when you're not using heat, you don't use a round bottom flask. Use only a flat bottom flask. So there's no heating. Is this clear? Now, what are the what are the precautions you have to take when you're conducting this experiment. The first experiment is the apparatus has to be airtight. Secondly, you have to make sure what's the matter. You want to take the lesson, come in. Come in the lesson, come on, correct. The apparatus has to be airtight. The gas should not escape because, and therefore there should be no fire close by because hydrogen is highly inflammable. So there should be no fire close by. And apparatus should be airtight. No escape of the gas. No fire close by because hydrogen is highly inflammable. And lastly, the thistle funnel, the end of the thistle funnel should be below the level of the acid. And the delivery tube, its end should be above the level of the acid. That prevents, if it is high up here, if it was here, then gas would go here, and escape from here, and the whole thing is bound to catch fire. So there should be no escape of the gas because hydrogen is highly inflammable. This is clear. So these are the precautions that you have to follow when you are conducting this experiment. Now the hydrogen that you have got here has passed through this water. Okay, though it is insoluble in water, some traces of water vapor are there present in the gas. And along with that, there are a lot of impurities. The first impurity is, say, for instance, hydrogen sulfide. These are impurities in hydrogen gas. In this gas, there are impurities. One is hydrogen sulfide. Second one is, say, carbon dioxide. Third one is sulfur dioxide. Fourth one is the oxides of nitrogen. And fifth one is phosphine. That is PH3. And sixth one is arsine. That is ASH3. And seventh one is water vapor. These are the 7 impurities that are present in the gas when it is being liberated, and they have to be taken out. This is where the equations come in, and that is here where you're going to make a mistake. So you have to remember to write down these equations 5 times each. So the first one, how will we take out hydrogen sulfide? To take out hydrogen sulfide, you have to add lead nitrate. And what are you going to get now? You're going to get PbS plus HNO3. This is what you're going to get. That's how you take out your H2S. How do you take out carbon dioxide? Take out carbon dioxide by adding KOH. How do you take out sulfur dioxide? KOH. Okay. How do you take oxides of nitrogen? Suppose oxide of nitrogen is NO2 plus KOH. All the oxides are to be taken out by potassium hydroxide. How do you get it here? You're getting K2CO3. K2CO3 plus water. Okay? Then here you're getting K2SO3 plus water. Here in this case, you're getting KNO2 plus KNO3 plus water. This is how you take out oxides of nitrogen. See, it's getting tougher and tougher and tougher. How do you take phosphine out? Phosphine and arsine are taken out by adding AgNO3. AgNO3. Because of the similarities in the reactant, I have put them together. I've clubbed them together. I'm clubbing this together. So here what you're going to get is Ag3P plus silver nitrate plus you're going to get nitric acid. Ag3, yeah. And here also you're going to get Ag3As plus you're going to get in AgNO3 plus you're getting, plus HNO3. Okay, this is what you're going to get. And finally, for water vapor, you are going to use a drying agent. You can't use a dehydrating agent. What is the difference between drying agent and a dehydrating agent? And difference between drying agent and a dehydrating agent.
Dehydrating agent like absorbs the water and then agent it removes the water.
What will you absorb the water and remove the water?
So it takes the water inside the distance.
Give me something, give me a clear explanation.
So, like dehydrating agent takes out the water from the like chemical.
From the chemical composition of the compound. While drying agent just takes out the water from the surface. So in this case, we have to use water vapor, for example, will be HNO3, H2O, H2O, water vapor H2O, plus you're adding calcium chloride. When you add calcium chloride with this water, okay, there's no reaction taking place. Calcium chloride just absorbs the water, like a towel absorbing water. No reaction, just absorbing. It's absorbed on calcium chloride. So that's why they're using this calcium chloride, okay, to dry up this water vapor, okay, to dry up the water vapor. And if at all, no reaction will take place, it just dries up the water, okay, plus hydrogen, plus your hydrogen, okay. So you're getting your calcium chloride is absorbing, this is taken out by calcium chloride, and hydrogen is set free. Suppose we had to use sulfuric acid. If we had to use sulfuric acid, hydrogen, that is water, plus your sulfuric acid, okay, what you're going to get is here. You're going to get your hydrogen sulfide plus you're getting sulfur dioxide. So there is no hydrogen at all here. Okay? Alright? The water is taken away, and what has happened is, no, sorry, not water, but you have to take the hydrogen is made to react with sulfuric acid, and this has got water in it. This has got water in it. So sulfuric acid is reacting with hydrogen, and you're getting hydrogen sulfide, and you're getting sulfur dioxide. Hydrogen is taken away only. Are you getting hydrogen here? No. But this hydrogen is reacted with sulfuric acid, and our hydrogen is lost. So therefore, we cannot use sulfuric acid as a drying agent. We have to use only calcium chloride, because calcium chloride only dries up the gas, does not react with the gas. Okay? Calcium chloride only reacts with water, dries up the water. You get calcium chloride, point water, plain water, and your hydrogen is dried up. You're getting calcium chloride, drying up the water, okay? The water gets absorbed at the surface of calcium chloride, and your hydrogen is dry. Right here, your sulfuric acid is taking out the water from hydrogen gas and converting it into hydrogen sulfide and sulfur dioxide. So this is why we do not use sulfuric acid as a drying agent when we are drying up hydrogen. All of you got that? Look at it carefully. Read till there, please. All of you till there. I'm going to ask you questions. Yeah.
Then what happens to the products which are given out in the reaction?
Which product?
Like the K2CO3,
No,
K2.
what happens is, I'll tell you what happens. All this, which one?
Like
This one, no?
the products.
See, what happens is, suppose the gas is taken out from here. So we set the saucer underneath, and we will keep it erect. Correct? And from there, a delivery tube. Suppose this is your flask here, which contains your hydrogen gas. Hydrogen gas, correct? Now, this has got a test tube. This goes into another flask, okay? Another flask, okay, containing what now? KOH. Okay, it contains KOH. In this KOH, your what is taken out? Carbon dioxide is taken out, sulfur dioxide is taken out and NO2 is taken out. And your K2CO3, K2SO3, KNO2, KNO3 are settling at the bottom of this flask. Now whatever is left behind, whatever is pure, is then again taken out and it is passed through your silver nitrate. It's passed through silver nitrate, okay? Silver nitrate. It's passed through silver nitrate. When you're passing it through silver nitrate, your phosphine and your arsine are taken out with nitric acid, and what you're getting here, you're getting these products all at the bottom of this flask. Then you have got your gas containing only moisture. In this you're putting calcium chloride. So we are getting this at the bottom, and your hydrogen, dry, free from all impurities, is collected by the downward displacement of the gas again. Okay? Long process. Have you followed? Is this clear? Hydrogen is why the gas jar kept upside down. Why do you think the gas jar kept upside down, my boy? Why the gas kept upside down? The gas jar which contains hydrogen is kept upside down, not erect, kept upside down. Why? Why, Ian?
Then the gas does not escape.
Huh?
Then the gas does not
Why will it escape?
The hydrogen is a lighter gas.
It's lighter than air, so it will lift up the saucer and go into the air. All balloons contain hydrogen because hydrogen is very, very light. Correct? So therefore the gas jar is kept upside down to prevent the escape of the gas. This is clear? Any difficulty? Read till then. Quick, read till then. Then I'm going to ask you questions. When you are drawing your diagram, see that you draw your diagram straight. Don't draw the diagram which I have put on the board. I can't bend very low, therefore my diagrams are coming crooked. Don't draw any crooked diagrams. You've got your rulers with you, you've got everything with you, draw neat and straight diagrams, not like the one that I put on the board. Okay, add two separately to it. That we will come to the next chapter.
What is calcium chloride? Use calcium chloride.
That is your solid. But it's not solid. Make it calcium. Calcium chloride in the form of a liquid is called fused. Like molten. Molten. Another word for molten is fused. That's value. Have all of you finished reading or you're still reading? Answer me, are you still reading or you're finished reading? Huh? Okay, so I'm going to ask you questions now. So, here, that boy in the back. How do we prepare hydrogen in the laboratory, the last boy?
How shall we do something?
You can close your book. What difference does it make? Keep the book wide open, but make sure that you don't lose it, that you don't use it. That's important. Hiding the book, closing the book does not make any difference. It's like this, children. You have to have very strong willpower. Suppose there's a drunkard in the house. What do? They can run away and hide the bottle. It is not going to help him out. He'll go out and he'll drink. He'll go out and his willpower doesn't allow him to abstain from drinking. So somehow the other, he will go and get that liquor. So don't try to control him by taking away the bottle. Keep the bottle there, make him sit in front of the bottle and make sure that he doesn't touch the bottle. That's the short test of willpower. So keep the book wide open, but control your eyesight. Focus on the thing on the board. I'm not running on the board. Everything what is in the textbook is on the board. Learn to read from the board. You tell me, how do we prepare hydrogen in the laboratory? That last boy. Come on, hurry up. Look here and tell me. Quick, don't waste my time. I've got a lot to do. I've got a lot of portion to complete. Can you read from the board? Then tell me. I have to write one equation down, and that is zinc plus HCl will give you zinc chloride plus hydrogen, or if you're taking zinc plus H2SO4 will give you ZnSO4 plus hydrogen. Okay, yeah. Balance it. Come on, you tell me. Hurry. Yes, you, the last boy. What's your name? What's his name?
Christian.
Come on, answer. What are you doing? I'm asking you to read from the board. You want to answer, or you don't want to answer? You don't want to answer? Come here. Come here. Why you don't want to answer? Why you don't want to answer? Answer me, tell me. Why you don't want to answer? You want to answer? Do you want to answer yes or no? Tell me. So what are the chemicals that you use for preparation of hydrogen? Go sleep. You, come on. What are we using for the preparation of hydrochloric acid? For the preparation of hydrogen.
Zinc, hydrochloric acid, will give you zinc, chloride, and hydrogen gas.
Are we using? Can we use any other acid besides hydrochloric acid?
Sulfuric acid.
Okay. We are not using one moment. We are not using nitric acid here, and nitric acid is also an acid. Oxidizing agent. It is. Its behavior is slightly different. Do not touch nitric acid. Okay, sulfuric acid and hydrochloric acid. Yeah. Now, are we using zinc metal or why are we using zinc granules?
Because the zinc granules contain.
Loudly and deaf.
The zinc granules contain some impurities.
Name them. Look at the board, you idiot. Look at the board. Everything is on the board.
Zinc granules contain copper as
Can you not see copper as impurity here? Can you read this or not? See you got copper? Huh?
Zinc was.
This is was? This is was?
It looks like was.
That's because when I was writing it down, you didn't pay attention to it. Okay, then what are the precautions that we have to follow when we are preparing this gas?
So the apparatus should be air.
Yeah, then
And also we can't use the downward displacement of air because then the hydrogen reacts with air even though it's lighter than it. So we use downward displacement of water. That, yeah, I read it. It was.
you have read rubbish and you have not understood what you read. That's the problem. That's why you're giving me that type of an answer. Yes, you.
It forms an explosive mixture with gas.
What gas?
Air.
Yes, oxygen at the air.
Ma'am, there was one precaution in our 8th standard book. But we have to let go the first few bubbles
Yeah.
so that we get pure
pure hydrogen, because if you have a presence of oxygen in the air, that will be explosive. Okay? The third next precaution.
I guess there should be no flame like heat.
No fire close by. Anything else?
The self-funnel should be dipped
Yeah,
side
the silicon should be right below, dip under the level of the acid. Okay, alright. Then the gas is liberated. Do you get pure hydrogen? Do you get pure hydrogen? Why? Why you said no?
Because we have to add something to get pure hydrogen.
Huh?
We have to add something to get pure hydrogen.
Why is it that we don't get pure hydrogen? What are the impurities? Tell us why you call it impure. Why is it gas pure or impure? The gas that is liberated, is it pure or impure? Can you read from the board? Can you read on the board?
Yes.
What is it?
It's a pure.
What are the impurities?
H2 is CO2, SO2, oxides of hydrogen, phosphine, water vapor.
Huh?
Water vapor.
After phosphine comes what? Can you read that English? What is it? Acid. Acid is it, okay now. How do we take out those individual impurities? How do we take out those individual impurities?
H2S can be removed, H can be removed by adding lead nitrate.
Okay.
Then KOH can be added to the oxides
Of what?
sulfur,
Look at the board. Look at the board.
sulfur, carbon, and nitrogen.
Okay, then
And then AgNO3 can be added to phosphine and arsine, and CaCl2 to the water.
you can't pick that from the board. Just say sorry to me. You are losing out on your marks. Or it is that you don't understand what I explained to you.
I understood. I was not sure about this.
Why is it that you don't use sulfuric acid to dry up hydrogen?
You get a purification of the gas.
You want me to come and give you a hard rap? That question is on the board there. Why is it that we are using calcium chloride and not sulfuric acid to dry up hydrogen?
H2S.
Yeah?
It reacts with the elements and it
Which element?
like H2SO2.
You idiot! It reacts with hydrogen. Why are you looking up here? This is the equation. This is the equation. What a stupid child you are. Can you not read from the board? Why are you looking up here? H2SO4 is here. It is reacting with hydrogen to give you hydrogen sulfide and sulfur dioxide. While in the case of calcium chloride, you're getting your hydrogen back. Here you're not getting hydrogen because it is reacting with it. Where are you looking? This is what happens when you don't pay attention to what I'm explaining to you. Talk. You're a set of idiots. Everything is on the board. You only have to read. So now you have got the individual impurities taken out from various flasks. Ultimately, the gas that you get there is absolutely dry. Why is the gas jar kept upside down? Why you put your hand up?
I could answer that.
Which one?
The question you asked.
Which question I asked?
You asked why is the jar upside down?
Yes, why?
Because
But I don't want you. This one I want to talk about.
because the hydrogen gas will escape out.
It is lighter than air, it will escape. Is that clear? And we will lose the gas. So now I'll about this. We go to the next part of it. Yeah. If you don't pay attention to what I am saying, it's better for you to pack up and go home. Don't waste your time here and don't waste my energy. I assume you have understood what I said, and I'm asking you a question. You are looking at me with dumb faces. Open up your brains and look at the board and pay attention. You don't understand, put your hand up. I'll repeat it 10 times. Now, what we did was industrial preparation. Now we are doing manufacture. Manufacture, difference between manufacture and industrial preparation. That boy. What's the difference between preparation and manufacture? That boy. Last boy. Do you know? What? Preparation is to prepare. Manufacture is to manufacture. Huh? Manufacture is to manufacture. And preparation is to prepare. Is that the answer what you give me? Huh?
Preparation is when you are making something or preparing something, and manufacture is when it is getting.
Have you seen my face? Have you seen how big my eyes are becoming because you're asking me some rubbish?
I'm preparing all this on the small scale and manufacturing was on a large.
And I'll ask it in the industry. Manufacture is industrial preparation. Preparation is laboratory. Preparation is small quantity. Now we are doing manufacture. And for the manufacture, we are using wash process. Wash process. Now, for wash process, we are using carbon and we are using water, which is steam. Hence, one monitor. Hello. Hello. हाँ बोलिए. Okay. This is wash process. So we are using carbon and we are using water, but water in the form of steam. To keep this water in the steam form, you have to continuously give it heat. So when we're giving it heat, what type of an equation is it? This boy. Don't look in your books, look at my face and look at the board. What when we're giving heat to a particular equation, to a particular reaction, what type of reaction is it?
We are giving, so it's absorbing, so it would be endothermic.
Endothermic. It is an endothermic reaction because you're feeding it, you're giving it. Endo means inside. So we're giving the heat inside the equation. So therefore, we have got this. And what do we get here? We're getting carbon monoxide plus hydrogen. This is called water gas. This is called water gas. This is a combination, not separated. Others will say, Miss, we can take hydrogen from here. No, this is a combination. You can't separate them. Now this water gas, this carbon monoxide plus your hydrogen plus water in the presence of a catalyst, Fe2O3 and Cr2O3, there's chromium oxide, which is a promoter. This is a promoter. Promoter means helping the catalyst. This is the catalyst. This is the catalyst. This is the catalyst. Okay? And this helps the catalyst to work more efficiently and faster. So, carbon monoxide plus hydrogen plus water, you are going to get now, you are going to get carbon dioxide plus you are going to get hydrogen. Now, these two are separated, so hydrogen is out, but it has got impurity of carbon dioxide in it. So how do you think we'll take out the impurity of carbon dioxide? How will we take out the impurity of carbon dioxide? Yes, Ian. How will we take out the impurity of carbon dioxide? Don't look in your books, close your books. How will you take out the impurity of carbon dioxide? Close your books. Do you know, Ian? I explained to you in the original first half of the chapter. How do you take out oxides of metal, of non-metals? Yes?
Ma'am, KOH.
By adding KOH. By adding KOH. So carbon dioxide, to that it is taken out by adding KOH, you're getting K2CO3 plus you're getting water. So that's how the carbon dioxide is taken out. Also it can be taken out by passing CO2 with hydrogen in cold water under 30 atmospheric pressure. 30 atmospheric pressure and carbon dioxide is taken out. Two ways. Either we pass it through KOH and you're getting potassium carbonate and water, or you pass it through ice cold water, very cold water, under pressure. So therefore, carbon dioxide is taken out. Then what happens is there is some unreacted carbon monoxide. Some unreacted carbon monoxide is also there, which has to be taken out because we want only pure hydrogen. So the unreacted carbon monoxide is taken out by passing through ammonical copper chloride solution. So therefore, what you have now is copper chloride plus carbon monoxide plus water. Because I said solution. Solution means water has to be there. Okay? And what you're going to get is copper chloride, point carbon monoxide, and hydrogen, and water is taken out. So that is how your carbon monoxide is taken out, and your hydrogen is absolutely free from unreacted carbon monoxide. Is this clear? Look at it carefully on the board. Which part of it, if you have not understood, ask me, I'll explain again. What coke is your steam? If you put steam, the coke automatically becomes hot.
There's molecule.
You have copper chloride and ammonia added to it, so it becomes basic. Ammonia is basic. Ammonia copper chloride is copper chloride in which you have added a little bit of ammonium hydroxide. So it becomes ammonium copper chloride solution.
What is the formula for
Which one?
hot coke?
Yes, go and steam 1000 degrees.
We shall read it. We shall read it. We shall read it.
Yeah, read.
Number 6.
textbook it is written like in the last reaction that CuCl plus CO plus H2. In the textbook it is written that the product is CuCl dot CO dot UH.
Dot.
So like H2O is separate or with CuCl?
Separate. That is the difference. What is that?
What is it?
Yeah.
Everywhere
Give me my textbook. But you can put the dot also, it won't make a difference. It won't make a difference, but ultimately you're balancing that equation. You have to balance it. To balance it. So therefore CuCl point is that H2O, CuCl, yeah. Same thing as here. Twice water. How many tests are we need?
Yes.
Have you all understood so much? Who has not understood the manufacture, please raise your hands. Can you explain to me the wash process at boy? Explain to me the wash process and the roll.
So steam is passed over coke around 1000 degrees Celsius. It forms water gas. Water gas
Give
is
us the formula of water gas. Give me the formula.
CO plus H2. So CO plus H2 is again passed over by steam and using the catalyst.
Not passed over steam. It is added to water. That is not steam. That is already water. Okay?
It's passed through water with the catalyst,
It's not passed through water along with water. Along with water.
and then the catalyst Fe2O3 and the promoter chromium oxide is used to form carbon dioxide and hydrogen. Hydrogen is liberated. Now, to remove the impurity carbon dioxide, we use either use potassium hydroxide or use cold water under 30 atmospheric pressure. Then, there are a few unreacted carbon monoxide and which are passed through ammonical calcium chloride
Called
solution.
copper chloride. Calcium copper chloride.
Copper chloride solution.
Is that Ca or Cu?
I miss. So it forms copper chloride plus hydrogen.
Plus hydrogen is hydrogen.
Sorry, water.
You can't see properly. Huh? What? Can you see properly or not?
Yes.
कुछ पी के आया है क्या तू? हाँ? सुबह did you drink a cup of tea or you drank something else? What did you say?
I drank water.
You're sure? Foolish fool. Now, in this case, where we prepare hydrogen in the laboratory, or we prepare manufacture, sorry, don't use the word preparation. In the laboratory, we prepare, we got only hydrogen. When we manufacture it by the Bosch process, we got only hydrogen. Now I'm giving you a process called electrolysis, which is an industrial process where we are getting two gases, oxygen as well as hydrogen. But this second method, which I'm explaining to you, the hydrolysis, electrolysis is, yes, it's also called hydrolysis. Electrolysis is very, very important because they're getting two gases, both important gases, oxygen as well as hydrogen. So it's very, very important that, so the second, this electrolysis is highly economical as when compared to wash process or even, of course, the water process, we can't talk about the economics of it because it's prepared in very small quantities. Okay?
In the second reaction, we said that H2 is water, but then in the H2 is steam. In the second reaction there, you said that
See,
H2
as
is
it was
water.
actually, it can be, you can use steam, but since we are using catalyst and a promoter, suppose this promoter was not there, then the steam would be okay. But here we are using the promoter to help the catalyst to work. Therefore, I can use ordinary water. This is clear? Have you understood? That is why. If you are using steam, there's no need to write down the promoter. But since I'm using ordinary water, I have to write down the promoter. Okay? I'll wrap this out now. Now we come to the electrolysis of water. Why are we learning this process? Why are we learning process? We have learned preparation, we have learned manufacture by Bosch process. Why are we learning the electrolysis of water? Because we are getting two gases, hydrogen and oxygen. So therefore, this is very, very important. So for this, we are using a very peculiar type of electrolytic cell. There is an ordinary electrolytic cell that we use normally, a simple one, wherein the cell is like this. The cell is like this. Okay? This is called acidulated water. Acidulated water means water plus traces of sulfuric acid. Because plain water is a very bad conductor of electricity. So when you add a little bit of acid to it, it enhances or improves the conductivity of water. So we call acidated water. And then we've got the two electrodes. This is your cathode, this is your cathode, this is your anode, this is your anode, this is your cathode, and we've got cathode and you have got the connectivity, and therefore the electricity is passing. Your water breaks up into H plus OH. H goes on to the cathode and OH goes on to the anode. Okay, so that is how the reaction takes place. I'll explain to you how this takes place in the other cell. Now, this is an ordinary cell. Very specialized cell is called the voltmeter. Okay, so it's like this. It's got a cell like this. I try my best to draw a straight line, but I'm not able to do it. Okay, you all draw straight lines in your. Okay, so you have Is it okay? Perfect. Here you have got platinum electrode. This is PT, platinum electrode. This is your anode and this is your cathode. Both of them are of platinum. Both of them are of platinum. And then you got the cathode connected. Okay. Now here you are adding water. This is your H2SO4 plus you are adding your water. Okay, it is added here. All right. And this is also very filled. This is also filled with water. Filled with water. Filled with water. But now here you have got your oxygen, and here this is oxygen given out at the anode, and here you're getting hydrogen. Here you're getting hydrogen given out the cathode. Now you notice that the quantity of hydrogen is double that of oxygen. Why? Simple. H2 plus O2 will give you H2O. Balance the equation. 2, that is 2. 2 2s are 4, 2 2s are 4. O2, O2. So you're getting 2 parts of oxygen, hydrogen, plus 1 part of oxygen, giving you 2 parts of water. So 2 parts of hydrogen. 2 parts of hydrogen giving out 1 part of oxygen. Therefore, one test tube has got half the quantity of gas, and the other test tube has got double the quantity. This is clear because water contains 2 parts of hydrogen, 1 part of oxygen. So this is your reaction. This is your specialized voltmeter. Now, how are the reactions taking place? You know fully well that water breaks up into hydrogen plus oxygen. Okay. Now, at the cathode, hydrogen. Okay, what happens is in the what should I say, in the electrolyte. In the electrolyte, hydrogen is breaking up into ions, and you're getting OH ions. You're getting hydrogen ions and
Can I inform you something? It's not in our syllabus.
what?
This electrolysis of water. Yeah, it's given that it's not in the syllabus.
Yes.
Like, and the lal is not even there. No, it is.
Oh, H minus.
Not only this much is given here. Just not this O, H and H. This is and then
Given cathode and
Don't do it. Don't do it. Don't do it.
No, but it is not in the first week.
yeah, it's
Read the next year. Examine. This is the water in the next year. It's the same thing will come next year. You don't want to learn it. Don't want to learn it.
yeah, mommy.
Okay, you got this. Then you won't go further than that.
Half. Like we learned this in our 8th grade. Yeah, 8th grade. We learned this.
But you got how the hydrogen.
Not this H and OH.
I'll explain the next way for about the problem. Pay attention here. You got your water breaking up into hydrogen ions and OH ions. Now, in the case of hydrogen ions, what happens is the hydrogen ion. Now, this is the metal. The hydrogen ion is accepting an electron. Ions accept. Atoms, ions of metals accept electrons. Metals give out electrons. Metals give out electrons. Ions of metals accept electrons. This is an ion of a metal. It's accepting an electron. And when you accept an electron, it gets reduced. So it will get reduced to hydrogen. It will get reduced to hydrogen atom. Hydrogen atom plus hydrogen atom will give you hydrogen molecule, and that gas goes and collects here. Correct? That is it. Remember that. Now, OH is an ion. OH is an ion. Okay? Now, what happens is it will give out? It will release an electron. And when it gives up an electron, it becomes OH. Okay? This is accepting. Non-metals accept electrons. But this is a non-metal ion. It is giving out an electron and is getting OH. Now this OH plus another OH gives you water plus oxygen. Oxygen plus oxygen gives you oxygen molecule, and the oxygen molecule is given out at the anode. When you are using, this is the basic you have to remember even next year. When you are having platinum electrodes, and the platinum electrode is at the anode, oxygen, only oxygen will be liberated. But there are other gases ready, other gases are present, they will only remain in the solution as migratory ions. They're migrating, but they're not getting deposited. Because the rule is, the basic rule is, if you're using platinum anode, only oxygen will be liberated there. Follow? That is it. So water was given out and oxygen. Water remained here and continued in the electrolysis, but oxygen was liberated at the anode. Why? Because the anode had platinum electrode. Till there, I won't go further. When I come back, I will do the properties and oxidation reaction. Remember oxidation reaction now?
Yeah.
So that's also cancelled.
No. No, the rest.
Chalo. Come on, read till there. Shall I ask the questions or you want to read?
You should read electrolysis.
Yeah. No, electrolysis don't read. What have I given? I didn't only like all this now.
Oxidation
I've already read it.
Yeah.
And I want to see electronic configuration for carbon monoxide.
Carbon monoxide, electronic configuration is always for an active, not for a molecule. Remember that. So you take carbon and you take oxygen separately. There is nothing like electronic configuration for a molecule. It is always for an active.
Is it balance? Is it balance?
What is balance?
It's CO. Is carbon monoxide balance?
It has to be in an equation to get balanced. It must be in an equation to be balanced. The products has to be equal to the reactive gas.
CO plus O2.
C2. How C2 does that mean? C2?
2C plus O2.
2?
2C plus O2.
2C plus O2. Come on, you take it rebalance it. But
Yes,
yeah.
C plus O.
It's 2CO.
So what are you asking?
Plus
What you're asking?
C6 O8. O8.
O is not 8. O is 2 and then 6 outside.
Yeah, 8.
8 and 6 has to be out. 1, 2, 3, then what happens?
So like you added the electrons.
I didn't know it's not like that. In a book, carbons and oxygen. It's not like that. So, that's a rare of language. Who gave you all the additional questions? I gave you. I didn't give you but the paper, how does very confident next year. What is the thing, the atomic number of carbon?
6.
Huh? 6. This is 2 and 4, correct? And oxygen is 1, 8. 2 and 6, correct? Consider like this. 1, 2, 3, 4. There are two lone pairs. Two lone pairs. Unacceptable disturbance. These are free. These are free. These are lone pairs. And covenant on what? Covenant on 4. 1, 2, 3, and 4. So what happens now? 1 goes here from this will go here. This will come here. Okay. Very complicated. Repeat. Just give me my mobile.
You will have to go to ask them.
The chemical properties is there though. How you be
You get the big
आने के बाद दीक्षा 5 क्लास में ये वाला
No, bro, I literally did not the
Have you finished the reading? Who is going to start also to speak and talk and gossip? Read properly from the very beginning, from where I taught you, read properly, very important. Write down those equations of how to know the impurities present in the liberated hydrogen. All the different 7 impurities that are there. Sulfur dioxide, carbon dioxide, nitrogen dioxide, phosphine, arsine, and water vapor. This is not in your goal, don't learn it. Write down those equations 3 times.
One carrot, two strawberries.
Write them down, yeah. Write them down. Write down these equations 3 times, all of you. Those ones, the impurities. Impurities, come on. All the impurities.
Study of the first element hydrogen.
What about the transcription all over? Finish? Please give me the book. I have to come and ask you. Please give me the book. Then, where's your book? Your mother's writing at home. Then, why you bought that book? For what? Your handwriting is just the same. It's making no difference. Don't bother. Write rubbish. Match your own feet.
On which line should I write in that hand?
You bring it to me first, I'll write it down. You don't write your own stupid work in that book.
Take a bit.
Then you'll say, Mrs. Logo, write it down. Yeah, goes back to the process. Oh my God.
Should I wash my hand?
Iron plus FeCl will give FeCl2 or FeCl3.
Iron plus
HCl.
Let's see which iron are you using? Are you using ferrous or ferric?
It's not given.
So then you write on both. You can be taking Fe plus 2 to the FeCl. You You're taking every class 3, what is your here? See what you're taking. Where is your correct?
I'm up to like NO3 also.
NO2, only NO2. Sulfur dioxide, carbon dioxide, NO2. That's all. Don't go finding more complicated than that.
Lecture is over.
You think I need you to tell me to leave the classroom? Kada?
Foolish fool from fourth.
Yeah, and it does cool
In real life, I can't give seats. Where does it allow us to? Bamboo. 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 It's just became a